Now let's put it all together. Let's try to apply the theoretical probability theorem and the counting principle at the same time to find the probability of this problem to the right. So we have this scenario. A license plate consists of, let's say, 2 letters. I know it's 3 letters in Minnesota, but let's say it's 2 letters followed by 3 digits. Okay? The letters are A through Z. Now know that A through Z, there's 26 letters. And the numbers are 0 through 9. Now a lot of people think there's only 9 numbers in there, but there's really 10 numbers from 0 to 9 if you count them. Okay? And they can be repeated, okay? The A through Z, you could have AA000. It's okay to be repeated. That's a key term right there. And it says, find the probability that your new license plate contains the initials of your first and last name and in their proper order, okay? So we want to find the probability that's happening, okay? So we're going to use those buckets that I talked about previously. And I have it set up here. The first thing we want to do is find the number of outcomes in the event. That's going to be our numerator. Part 2, we're going to find the number of outcomes in the sample space. That's going to be our denominator. And then we're going to put the numerator or the denominator to get our final solution. Okay? So our first letter, for me, I'm going to use these buckets. Remember, we multiply these buckets. My first letter of my name is Rob, so it's R. How many different ways can I do that? There's only one way. I got to choose R, right? So for my first bucket, it's going to have a 1 in it. And my second letter is B for Benson, and there's only one way to choose B. It's just choosing B. So again, there's a 1 there. Now here's where it gets a little different. The first number could be 0 through 9. How many different options do I have for that? Well, I got 10 options for that. And the second number, since I can repeat, I also have 10 options for. And the third number I have 10 options for. So to find the number of outcomes in the event, it's really 1 times 1 times 10 times 10 times 10. And if we do that in our heads, we would get close to 1,000. Actually, not close to, exactly 1,000. Okay? Now let's find the other part. Okay? Find the number of outcomes in the sample space. Again, we're going to use our buckets. Okay? Now this one's going to be a little bit bigger because the number of outcomes in sample space does not have to start with RB. How many letters could I have in this scenario in my first spot right here? Well, there's 26 letters in the alphabet, so I'm going to use all 26. There's 26 options. And the second one is there's 26 letters, so I have 26 options again. And the numbers again, I have 10 options per digit. Okay, and we're going to multiply these all together. Now this one's not as easy. I know that this times this is 1,000 times 26 is 26,000. So whatever 26 times 26,000 is, we've got to figure that out. Well, let's just figure this out. This is equal to 1,000. That's from this, right? And the bottom is 26 from here times 26,000 from there. Now we just got to get our calculator open up and solve that. So what is, let's see, sorry I didn't have this open right away for you guys. So we got to figure out what is 1,000. Oh shoot, delete that. There we go. Okay, so second quit. We got 1,000 divided by, and then in parentheses 26 times 26,000. Okay, bam, equals 0.001472. Okay, okay. We're gonna slow down on that one. So we get this is equal to 0.001479. Let's just say that's what it is. Now that is our decimal. We want to figure out the percent of that. Let's figure out the percent of that. So how do you figure out the percent of it? You just take this decimal point right here and you move it over 2 spots. Bloop, bloop. And so the percent probability would be 0.1479% probability of getting your license plate that has an R and a B first, or your first 2 initials, in the correct order.